Start recording. All right. So today we are here and we're sharing the screens, which is good. Today's class is all about electrical. And we are going to review a set of electrical plans for a Popeyes, Louisiana kitchen. And the unique thing about the electrical set, regardless, besides all of the symbols that you'll have to memorize, and this gives us our cover sheet for the electrical, gives us a few. But big projects, you may have 100 different types of symbols, and you'll have a symbol for the lighting plan, symbols for the power plan, symbols for the data and communications plan, for the fire plan. All of that is comprised within the electrical set. And so the more and more you perform electrical takeoffs and estimates, you'll be able to memorize the different types of symbols and what they mean. Some are standard. So when you see this J in that circle, that's a standard junction box. That never, ever changes. It may be on the wall or on the ceiling or in the floor, they'll tell you, but that symbol pretty much never changes. And another symbol that usually never changes is the data and outlet, black and white. That usually never changes. So where telephone is black and data and telecommunications is white. So those usually never change. But depending on the architect, they have the liberty to change the symbols in any kind of way. So just make sure you look through your symbols list first before you start doing the takeoff. So the unique thing about a set of electrical plans is that we have two separate plans. One plan shows us everything we need to know about the light fixtures and how they're controlled, and the other plan tells us all about the power and what's powered up. Okay, so we analyze each of the sets of plans separately, and the way that they mark the devices are different depending on which plan you're looking at, and all of that means something. So we want to give you a good general knowledge of what everything you see on here is. Now, we're looking at the lighting plan, so it shows us all the physical location of where each of the lighting fixtures are, where they're located. Each of the fixtures have a different mark, or it's named something different, and of course you're going to have a lighting schedule, all right, a light fixture schedule that's going to tell you however the mark is where it's identified on the plan. Then it's going to tell you the type of light, and it'll go to the manufacturer, the manufacturer's number, the type of bulbs and wattage of the lamps that actually go into the fixtures. Okay, so doing the takeoff just basically means counting all of the different types of lights, and that's usually the first thing we do when we do an electrical takeoff. And remember, takeoff is just a technical term for measurements that you're taking off of the documents. And so when we're looking at the lighting plan, we're looking at where all of the individual lights are physically located. And so some lights are named LL2, some are named LL1, LL4. These are A lights, okay? Why that's an LL4 right there, I'm not really sure. That's a mistake, and you'll find a lot of mistakes because it can't be an LL4 and an A light at the same time. So those are mistakes that you'll find, especially on this set of plans. Okay? So now, the lighting plan tells you about the lights and how they're controlled. Okay? So we know that the mark, the LL4, that is the name of the light based on the lighting schedule. Now, the next digit or the other letter that's next to the fixture basically tells the electrician which of the lighting controls that light is connected to. So when you go into a restaurant, you can cut off these lights or that light, keep some on, shut some off. Well, this tells the electrician some lights are controlled by panel A, lighting control A. Some are controlled through lighting control E. Okay, and so the lighting plan is going to tell, and some are B. And so somewhere on here, which is what I'm panning into right now, that's just a representation of the lighting controls. And when we go through symbols for the electrical, we know that the $sign is representation for a switch. Okay, so that's just basically telling us that is where our switching mechanism or our master switches are located on the plan, and that pretty much in that vicinity. And we have lighting controls that go from A all the way to E. Okay, and so some of the lights are controlled by the A lighting control, some by the C, some by the E. Okay, and so that's what that means. Now, when we talk about the electrical, it's the fixtures, and what we don't see on here is the conduit or the wire that connects the lights. And so also doing the takeoff, you got to kind of have an idea of how much wire you need to connect these lights, because they're connected together, and then they go to the power panel, they'll go to the lighting control that it says that they're connected to, and then that lighting control circuitry is connected to the power panel. Okay, and all the power stuff that we're talking about is on the power plan. Right now, we're analyzing just the lighting control plan, and again, the lighting control or the lighting plan tells us all about the lights, where they're located, and how they're controlled. Okay, so when we say that, we look at the marked lowercase alphabet. Okay, that tells us how they're controlled. Now, the lights can be controlled in two ways. Okay, I showed you one way through the lighting control, lowercase alphabet. So I know that this LL4 is controlled by lighting control A. This LL1 is lighting control D, small lowercase alphabet. Some lights, in the terms of this E light and the H lights, some lights can be controlled directly through the panel, which means they're not controlled by a lighting control. They're directly connected to the panel. So when I say directly connected to the panel, that is what this is telling us, or telling the electrician. B/30, this light is called E. We've named that E. The circular one is H. Okay, and they are connected directly to the lighting panel. I know that because this is how they represent the panel and the position on the panel. Just like in your home, right? You have a panel that's probably 8 or 12 breakers. Well, in commercial, we have panels that are 24, 48, 64 panel breakers. It really depends. And so what this is telling us is that this light E, this light H, they're connected to position 30 on panel B. Okay? And so basically all of these are connected together. If we're talking about the physical connection, because we have to physically connect wire, right, to the light to power it up. So it goes from the fixture, we connect it, and all of those are connected together. And so we go back to, how do we determine the conduit? We know we can count the lights, so we know how much the lights cost, so we can determine that cost. But we also need to be able to determine the conduit. Conduit, fancy term for the wire, and the wire basically, and what it's ran through, and how we connect the lights. So how much conduit do we need? And we physically connect these lights, right? We have to physically connect wire to these lights. So, long story short, we know that any of the lights that are going to the same lighting control panel, that's this pink line, all of these LL4s are connected to lighting control panel A. So we know that we can physically daisy chain, that's what they're called, just physically connect them in series. Series means they're all in one line, right? So we can physically connect these all together because, why? They're all connected to the same lighting control panel. So we can connect this light as well if we were going to continue. All of these Ds, they can all be connected together. So that helps us to determine some actual physical length of conduit. And then once we get to the end of any one of these chains, the very end of it, we know, because rule of thumb is, we have to connect it to the lighting control panel. So a couple of things you need to know is, where are the panels at? And the bad part about it, for a lighting plan, they don't show you really like they should. You have to go look for it on a lighting plan, okay, for the panels. For the power plan, it shows you in every detail. But these are the panels right here in this gray area. So just keep in mind, construction tries to be very strict, okay, because the panels are a component of a power plan. They are showed in detail on the power plan, okay? They just kind of outline them here to kind of give you an idea where they're located. They don't even show you where the lighting control panels are located. They just show you here where the switches are located for the control panel, but they don't really show you where the panel is located. So keep in mind, in electrical, we're only talking about electrical. We have two plans. One's the lights and their controls, and one is the power we haven't gotten to yet. So anything related to power will not be shown on a lighting plan, okay, period. Okay, so your power panels, you got to kind of look for them and figure out where they are. And sometimes they don't even do this. So this is DP, that's the distribution panel. It's usually MDP, main distribution panel. So DP is the distribution panel, and then we have panels A, B, and C. Basically, think about it this way. Our utility brings in 420. Our transformer transforms it down to 12208, and it goes through the distribution panel. So that's like the mother of all the panels. The main main power comes through the distribution panel, and then is branched off to A, B, and C. Okay, so we'll see that more on the power plant. Okay, so lights and their control. So basically, long story short, the lights on your plan can either be controlled through a lighting control, lowercase, or directly through the panel. And then certain lights, because they want them to be emergency lights or lights that come on when other ones go off, those are the ones that are typically controlled directly through the panel. Okay? So that is the lighting plan. One of the two plans you'll find on the electrical tells the electrician where the lights are physically located, and also how are they powered up? What are they connected to? Are the lights connected through a lighting control, lowercase letter, or are they directly connected to a power panel, which is the panel name, basically, uppercase, and the position on the panel. And we know that panels or fixtures that are connected directly or connected to the same lighting control, basically when we talk about the conduit, they're all connected together too, and at some point we're going to take that end and connect it to the lighting control panel itself. All right, so this is representative of LC1, lighting control 1, and these are called lighting contactors, and so the electrician knows how to connect each of these, and these are basically just switches that are contained within its own little mechanism. One end of the switch is the light. The other end of the switch is the panel, the B panel. See, the other switch are the lights, and then the other portion is where this is powered up. Okay, so this represents LC1, LC2, LC3, and that's no typo. Okay, so this tells the electrician how to physically connect the little bitty devices, and they are little devices contained within panels, metal panels, and they physically connect the wire from the lights and then back to whatever panel the lighting control circuitry itself needs to be connected to. So it's showing you all of that stuff. Okay, light schedule, fancy term for list, and gives us all the list of all of the fixtures, manufacturer. So eventually, you got to order that, and typically what the electrician will do is when they get the plans, they'll order these right out, or the GC will tell the electrician what supplier to go to, and so the supplier already know, you're doing Popeyes in whatever state, the lighting package, which includes all of the lights, okay, and this is something I just learned over this last couple of years. The lighting package will include all of the light fixtures, but also the ceiling and door occupancy switches and overhead occupancy little circle things that that let you know you're in. It cuts the light on. That's part of the lighting package too, because it's part of the lighting control. So a lot of times those things are really hard to price, but you don't have to worry about it because it's priced within the lighting package. So that's beautiful because that makes sense. It controls the lights, and so it is part of the lighting package. So that's cool. All right, so that's the first plan in the electrical set, where the lights are located and how they're controlled. And remember, every sheet gives you a list of notes as to what to do. So always make sure, especially with electrical, because they'll tell you some things in words that they don't show in pictures, and then you don't do it. So make sure You know, you follow all of the keynotes. That's what these are called. Every sheet, every plan is going to give you keynotes because it's going to tell you to do something or clear something up. So make sure you always follow the keynotes. All right, electrical set, 2 plans. We just went over the lighting plan. The lighting plan tells us all about the lights and how they're controlled. They can be controlled 2 ways, either through a lighting control circuitry. That is depicted in all cases by the lowercase alphabet. When they are controlled by the panel, which means they're directly connected to a panel at a certain position, that is depicted or shown by an uppercase alphabet and the position of the panel. All right, so the next set, which is a little more complicated and a lot more symbols, is the second plan in the set of electrical, which is the power plan. Okay, so it's going to tell you all about your powering devices. Powering devices are those things you use to power up stuff. So a powering device is an outlet, right? We've got the outlet shown, duplex outlets as opposed to quad. This is representative of a duplex outlet. So that means that's basically the outlet you have in your wallet. You can plug 2 things in. Duplex, if it has 4, that's a quad. So, you know, all of these symbols, you got to make sure you know what they're telling you. If they give you this inches, they're telling you AFF, right? What's AFF? Above finished floor. So what they're telling us there, telling the electrician, that outlet in particular, we want it 2 feet off the ground, where the other junction box right there, circle J, we want that 72 inches off the ground. And something is waterproof. Okay, that's waterproof, these things. All right, so some more important symbols that come from the power plan. Okay, so a couple things that are important. So you see here, everything on the power plan, what, is directly connected to a panel at a certain position. And very rarely do you see wiring devices daisy-chained or connected in series, maybe in one room. But, you know, as you can see, each one of these are going to different positions on the panel. It's not like the lights where they're daisy-chained. You may find a few that may be, but that tells the electrician that it's going to panel A, position 17. And this is a switch. It's a 2-pole, and it has to be waterproof. So a lot of symbols on the power plan that you don't get on the lighting plan, okay? Symbol that's really important is this little arrow right there. That's called a home run. Okay, so basically this junction box has, and we use junction boxes to do what? To hide connections, right? So these won't be out in the open for people to mess with or for the elements to corrode or whatever. And so we've connected this condensing unit, usually that's used to make stuff cold or to make ice. And keynote number 3 is going to tell us all about whatever it's pointing to. And so the electrician has a lot of different things to look at when it comes to his power plan, her power plan. You know, you gotta make sure you follow all the keynotes. You got to make sure you look at everything in detail because you don't want to miss something. Okay, so what is all of this? Now, home run. A home run means that that wire is going from that junction box directly to where that panel at 3 positions. Okay, so we have what comes into our just a little electrical background on power, right? We use alternating current. So it alternates from 12208. It's a 3-phase, 4-wire system, right? We use 4 wires to connect our devices, up to 4 wires. Some you don't need, some you do need more, depending on the type of device. And so we have a 3-phase system, hot, neutral, and ground. Okay, so at any one point in time, depending on your piece of equipment, it may need to be connected to all 3 phases. Okay, so that is the condensing unit F, right? It needs to be connected to all 3 phases. So what that's telling me is at the distribution panel, it's connected to position 8, 10, and 12. Okay? Under that, it's telling you what kind of wire. Okay, so let's do some more electrical background. Remember, coming into our homes, we only have the standard 12208, 12208 alternating current, right? In the 1900s, Edison and fought each other to see what we would have at the World's Fair, right? DC versus AC. Guess who won? AC, right? Because if we tried to power our homes with DC, oh Lord, how would we recharge those batteries, right? That's why electric cars just barely getting on the scene, right? All right, so we have AC, and that's what we have in our cars too, right? Alternators. Well, I don't know what they're called now because cars are new, but they do the same thing, where they keep your voltage, keep your power going through that alternating current situation. Okay, so that's the only thing that we have is that alternating current. 12208, 12208. Okay, why does it smell like something's burning, as a matter of fact? I really hope not. These people wire up this complex like crazy. They got stuff going everywhere. You can't do two things without something popping. All right, so 12208. That's all we have coming in. And so the only thing we can do, because we have to power things like everything from our charging our phone, right, to a microwave to a rooftop unit. So how does that same 12208, 12208 be enough current for our rooftop unit, but a little bit to charge our phone? Well, we do that by the wire that we connect from our charger cord, right? That is what knocks down or boosts up. Same thing with the condensing unit. The cord and all of that is given, and the requirements. So this is what that is. Okay, so when you see 3 number 10s and 1 number 10 ground, that's what number 10 ground. Remember, we have the 3 system, 4 wires, 3 phases, okay, in a 3 1/4 inch conduit. Okay, so the only way for us to give condensing units and chargers the power they need, because all we get is what, 12208, is by the configuration of the wire that is, and that's what that is. That's telling the electrician for that, only for that condensing unit. So that wouldn't apply where it's not stated. Okay, so for that condensing unit, what they have to do is connect 3 number 10 wires and 1 number 10 as ground, and they'll put it in a 3/4 inch conduit, okay, and that's how they power that. Okay, so the only way to change and to give the power requirements for the condensing unit or for an exhaust fan or for whatever, they have to make those adjustments in the wire. Now, why doesn't everything tell you the wire size? Because typically, if you look in your notes, in your power notes, and electrical is a pain in the butt. It's a whole lot of stuff, I know. But, it is and it isn't. So typically in the notes, it'll tell you the wire configuration generally, unless otherwise noted. So for that condensing unit, it was otherwise noted. So we know to run that. Well, usually it's 3 wires that's required, and it's 3. They usually use number 12. Okay, so just know that is an assembly. Okay, that's telling us. Now let me, and I don't have it open, so just 1 second. Open up Craftsman Estimator, and I'll give you an idea. Because again, the only way to alternate or to boost up or slow down that 12208, that standard, is by the wire configuration of whatever the power cords we get with our electrical stuff. Okay, so let's see. Let's do wire. Are we in? Yeah, building wire, copper. Here we go, because all wire is copper. All right, so that is all of the different types of variations of wire. Okay, so that's one strand. Okay, so when they say 3 number whatever and 1 number, well, they mean, actually 3 physical strands. And that's how much. So if you've got, 100 feet, then you really need 300 feet for the configuration, and then another 100 foot for the ground. Okay, so that's how it's represented. So you can have the ones at the bottom, that's more for power. Okay, so remember, when we talk about electrical, the more, the more copper something contains, the more electrons are going to flow through it. Okay, and so those 500 MCMs, those are big, thick strands, as opposed to the number 14. And so that's why they use the 1/0 all the way down to the 500. Oh, the number 1s are usually used for power too. Okay, because you get a lot of conduction when you're using that number 1 gauge all the way down to the 500 MCM. Those are usually used for power. Coming out of your power panels, there's some type of configuration of those. And then the other ones from number 2s on up are usually used for everything other than power. All right, so let's go back to the plan. Okay, so what we're looking at are all of our powering devices. Usually, and on here too, they do have the data symbols too. So it looks like in their kitchen area, somehow they have some kind of communication going on with maybe the exhaust hood, or who knows, ordering or something like that. The menu might come through there. So that's why we have those white triangles, because the white triangles represent data and telecommunications, as opposed to a telephone, which would be black. Okay, so you see the different outlets. That's a specialty outlet, the ones that look like the little Ys, okay? And that's a different kind, integrated ground. So there are so many different powering devices. So, but all this is telling the electrician is each of these outlets will be in a specific physical location, and that is telling the electrician what panel, right, and which position on the panel that those wires need to be connected to. That's all we're looking at. So anything that needs power would be depicted on this power plan. And remember how I was saying before, on our lighting plan, it just kind of gave us a vague outline of the power panels. Well, here on the actual power plan, it shows us in great detail everything connected to it, everything about it. It's all in black, and we know that dark black usually means new construction. Okay, so everything that needs power is going to be shown on your power plan in very good detail. So symbols for fans, that's a symbol for a switch. $sign always a switch, but what type of switch? It'll have a little subscript on there. So that switch is one that will turn a motor on. Those switches have to be stronger than a regular toggle switch to turn on a light. Okay, so everything that needs power would be shown here, and it would show you which panel and position that device has to be connected to. And remember, that's a home run, so we don't want that end of the switch going anywhere but to panel A, position 2. Okay, so this is all of everything that needs power. All of those are pretty much outlets and junction boxes, and just showing you where they are and what panel they're connected to. And you know that assembly, that right here, that signifies a wire assembly, where we have 3 number 10s and 1 number 10 is ground, and we put it in a 3/4 inch conduit. Okay, and let's show you real quick conduit sizes, because they could range. You have PVC and EMT. The PVC is the plastic, really tough plastic, and we use that underground. EMT is usually what we use in the building. And so, here we go. Oh, no, that's just individual pieces. Okay, there we go. All right, so it shows you all the different sizes that EMT can come in. So electric metallic tubing, So it ranges anywhere from a ½ inch to 4 inches, and then it gives you separate prices for the elbows and stuff. Okay, so 3/4 inch is only 43 cents a linear foot. Right, so but 4 inches is $6. And so typically the electrician would have to provide, let's go back to that. Anywhere we see these data triangles, pretty much, that lets the electrician know, because the electrician doesn't supply any telephone outlets, any low voltage wiring for speakers and fire alarm systems and Muzak and HVAC, all of that. That wire, that's considered low voltage wiring. The electrician that does the outlets and lights and stuff, they don't provide that wire. But what they do provide for, even for telephone, televisions, all of that, the electrician provides a junction box and conduit that will take their wire from the box itself to just above the ceiling to kind of hide the wire. But from that point on, the telephone professional, TV person, whatever, takes their wire and runs it from that point on. Okay, so the electrician, again, only provides junction boxes and conduit for anything related to data, communications, telephone, closed-circuit TV, anything like that. Okay, so the electrician knows, okay, I see some of these, so that's junction box only plus conduit. So that symbol basically means that to the electrician. So, all right. Got a little call during class. That's not acceptable. All right. So, electrical power plan. We have two, and then it's going to show us, a little elevation view of the drive-through. So, it's going to show us that. So that's the duplex outlet, right? We need a special little junction box for some of the other stuff. Shows you the conduit underground and how it's going to come up. Okay, now, remember how we said we've got 120, 208, 120, 208 coming in our house. Standard, our offices, everything. But the equipment that we are trying to power up may, need more power or less power than that provides. And the only way to vary that or to give a piece of equipment the power it needs is to vary the wire that connects the device to the outlet, all right? And the outlet connects the device to the power, right, through the power panel. So what we're looking at here is this lets the electrician know each of the equipment, it marks the equipment, and then branch circuit conductors. So that's basically the wire requirement from the back of the equipment to the outlet. Okay? So the electrician has to physically run those wires and make sure the outlet that's associated with that particular piece of equipment has that particular wire configuration. Because if it doesn't, then that's when we get to popping breakers and stuff, right? Because we're putting, say for instance, the double-deck oven down there, B10, it needs 4 number 10s and 1 number 10 ground. But what if we connected it to a 2 number 12 and 1 number 12. Chances are every time we cut that on, it's going to break the breaker. Okay, so that's a physical connection that has to be minded and made and make sure, because now you know anything in your house that just pops when you think it shouldn't, they probably did something or running too many circuits to one breaker. That could happen too. Okay. So the electrician has to be mindful of the wire configuration. And the majority, as you can see, are number 12. So, yeah, we usually use 3 wires, 2 number 12s and 1 number 12 as ground. That's the majority of everything, but sometimes it varies. And the electrician has to be mindful of the variation. And that's our 12208, 12208. So, all right. So that's the equipment schedule. Okay, last but not least, something that's very important is the single line diagram. Okay? The single line diagram, which is right here, and if we start from the right and work our way left, it basically gives us all of the power components and the power feeders associated with each of the panels. So the electrician knows how many panels, how many lighting control panels he or she has, what kind of main distribution we have, what kind of breaker system, and do we need to install a big T, a transformer, right? Because we get 420, 480, something like that from the utility. Now I forget, I'm mixing them all up. I'm mixing up National Days of Marijuana Smoking with electrical. I forgot. All right, so single line diagram shows you all the power. It has nothing to do with the lighting other than how the power for the lighting, the LC1, LC2, LC3. But the single line diagram shows you from transformer that brings in that transforms us down to our 208, 120, 3-phase 4-wire system. And this shows us underground. So this is telling us that concrete pad, okay? So this is telling us the wire, the power wire. Remember I told you that 350, 500 usually that's for power. And so it's telling us, or tell the electrician, what we need to connect the transformer to now our main breaker system. And we need 2 routes or 2 runs of 4 350 in 2. I don't know why I said 2 because you don't need 2. It's just we have 2 runs. So 4 350s each, and we have 2 runs of that in a 3.5-inch conduit. Okay, so that's what that is. And so the single line diagram shows you all the power and how it comes in, the breakers, the main distribution panel, okay, shows you panel A, B, and C, the lighting controls, and even roof-mounted photoelectric sensor switch that turns the lights on, and off when the sun comes up and down. And then here are your lighting controls that were shown on the lighting plan for the different sectors within the restaurant. Okay, so the single line or one line diagram is just a graphical representation, I guess you can say, of the power from transformer all the way down to all of the panels, including lighting control. Okay, shows you all the power conduits, all that's needed. And so here's another, with these rings. So it's showing you from panel A to the distribution panel, we need that kind of power conduit, okay? And it's going to show you all of that. Now, how many linear feet all of this is, then you go back to the plan and determine that. Okay, so that's the single line diagram. And then you're also given, the electrician's also given a panel schedule. So it shows us our new panel, and we'll use this just like we did with the lighting control, with the light fixture schedule. So this tells us what kind of panel we need to order. Panel has to, this one, the distribution panel, has to be at least 600 amps, 3-phase. It's going to mount in the wall, so it's going to be flush in the wall. A couple of things that's important. How many positions? This is going to be a 42, and you see they alternate, 1 on the left, 2 on the right. They alternate like that. But main thing, you just look for the bottom number. This is a 42-position panel. 12208, 3-phase, main breaker. So that means it has a separate main breaker as opposed to some of them just have main lug connections like this one. There's no individual breaker. Okay, and this is panel B, same thing. Now this one is 225 amps. So, that you got to be mindful when you order. One's going to be more expensive than the other because the more amperage rating, the more expensive it is, and also the number of positions. This is also 42. And then you have, this one's also 225. And this one, yeah. So A, B, and C are all the same, all 42 position panels. So within each one, it's going to show the electrician what's connected to each position. But the plan did the same thing, you know. So imagine being, and my whole thing is, imagine being an electrician that has to physically run the wire. It's like, is it all over the place? Or do you run it in, and some run it all over the place, some run it in cable trays, you know, because you're physically connecting wire to all of these positions. And all of that is above our heads and in the walls that we don't see. So I've looked in my office. I moved a couple of acoustical ceiling tiles, and it's just a spaghetti mess, okay? And that's bad. Because, you know, spaghetti mess, some sets on fire, it's just like so out of control. Everything is just burnt. But if it's nice and neatly, and most government projects require that you put it nice and neat. They have a specific route where they want all the wire to run, so it's not a spaghetti mess all above the ceiling. So that's your electrical set. 2 plans, lighting and power. The lighting plan shows you where all of the lights are located and how they're controlled. They're controlled either by a lighting control system, right, lowercase, or directly connected to the panel. Okay, we don't see our conduit here because we wouldn't be able to see anything else if we did see the conduit. But we know that rule of thumb, if all of these are going to the same lighting control, we can daisy chain, or we can connect them in series and branch them over to wherever that power panel, lighting control panel is. But you can take a lot of liberty when you get a set of plans like this. But the main thing is to put something as opposed to nothing. You know, you want to give it a good, educated guess as far as the conduit, and that's what I do all the time. And I've had some pretty good luck with my electricians. We won a lot. Because really, the switchgear is what it is. The light, you know, all of the fixtures are the price that they are. And the only thing you can play with is how accurate am I with the conduit and what kind of labor rate am I charging, you know. So we do pretty good. All right, and then the power plan tells you all about the powering devices. And when we say powering devices, those are outlets pretty much. You know, outlets and where all of the switches are located for any equipment that needs to be powered up. And then you also know about the single line diagram, that is a representation of our power, basically, from transformer all through to the panels, showing us how the power is distributed throughout the building. Also gives us indication of all of our power feeders. And we know that when we see something like 4 350s, K, C, ML, or one whatever, or 2 number 12s and 1 number 12 in a 3/4 inch conduit, we know that that is a wire assembly, and that is a physical 4 strands plus whatever inside the piece of conduit. All right, so that is it for this electrical class. I'm sure you're much more smarter than you were when we started. And I would like to thank you for joining.